Alright guys, so we're going to pick up today with lesson 2, which is going to be weather systems. Alright, hopefully you all have turned in your vocabulary. Hopefully that wasn't too difficult. And just like we did yesterday, if you need to hit pause so you can fill in your notes as you're going along with this, make sure you do that. That way your note set is complete. Also, if there's any concept that you're like, wait, he went a little fast, just hit pause or rewind, go back a little and listen to it a second time. I will definitely review all of this stuff on Thursday. All right, so yesterday we talked a little bit about wind, and here we have a focus of why do winds blow in the direction they do. Now this one, unlike some of the other focus questions that I'll look at, we kind of already know this answer, right? Because we said that when we have cold air that is high pressure, right, that cold air that's high pressure is going to move toward warm air that is going to be low pressure. And just to recap what we're talking about there, it doesn't hurt to say it numerous times. Warm air rises and cold air sinks. So the sinking air creates the pressure pushing down, and therefore it's got to go somewhere, so it's going to go where there's less pressure. So a quick overview of some of the vocab we're going to need to know for this. So again, you hopefully have turned in your vocab, but the Coriolis effect, polar easterlies, prevailing westerlies, trade winds, jet stream, and front. By the end of this section, we should see how all of these different terms really help us to understand planetary winds. All right, so you're probably thinking, what exactly are planetary winds? Well, if you think about us having the Earth, right, we have the equator at the middle, then we have 30 degrees, 60 degrees, and 90 degrees. I'm going to go back and label those 90, 60, 30, and 0. These are all north latitude. And in fact, we're going to have areas where the air is going to sink. That's going to be around 30 and around 90. That's going to create high pressure. And then at the equator, we're going to have rising air, which is going to create low pressure. And over time, what actually happens is you get these surface currents that we're going to see are going to move down this way, move up that way, and then again move down that way. And this is where all these fun terms, polar easterlies, westerlies, come in. All right, so you'll see that in a minute. I've kind of gotten ahead, and again, this is one of those things that on Thursday I'll draw on the board, all the fun markers, and we'll have a really good sense of what we're looking at. Quick reminder about convection, right? Warm air rises and cool air sinks. So cool air sinking and warm air rising. And so warm air coming across, cool air sinking and coming this way. And the big idea is that you get this big convective mixing process. Okay? We have mantle convection, we have convection in fluids, and we're going to see today how convection actually happens in the atmosphere. So, we just looked at the quick sketch on planetary winds, and this relates back to Earth's winds. So here it says the direction of Earth's winds are influenced by Earth's rotation. Now, Earth rotating, if you think Earth rotating counterclockwise, then we're going from west to east, and that rotation then, if an object is trying to move vertically on the Earth's surface, it's going to get deflected, or its apparent path is going to get curved because of this Coriolis effect. So you probably want to hit pause and fill in some of the important points here on the Coriolis effect, like the apparent curved path rather than a straight line. But I'm going to actually sketch in for you this idea that if you're on the Earth and you're at the pole and you decide to throw a ball toward the equator, by the time it gets to the equator, it's going to hit a point that was further behind because the equator is trying to move in the east direction. So by the time whatever wind or object is moving toward the equator, it will actually hit a path to the right of where you're going. Now, the Coriolis effect is way more complicated, and I don't kid when I tell you that my sister, who is a couple years older than me, is still flabbergasted by the fact that I teach earth science because she struggled with earth science, and it was the Coriolis effect that she could just never wrap her head around. All right, anyway, enough about my personal life. Let's keep going. So, the Coriolis effect is going to deflect winds to the right in the northern hemisphere and actually to the left in the southern hemisphere. We'll get into that a little bit later. But remember that winds are moving from areas of high pressure to areas of low pressure. All right, let's kick it up a notch here. If Earth's heating was not impacted by the rotation, so just imagine that we were on a planet that didn't rotate, well then you would just have two convective cells. You would just have cold at the poles and warm at the equator, so high pressure coming from the poles going to the equator. And that's what this diagram here is trying to show you guys. But in fact, we know that the Earth does rotate, and in fact, along the equator, we're moving at about 1,670 kilometers per hour. Now that's really fast. If you think about being at the poles, you could spend an entire day standing in one spot because the pole is going to be super boring, right? You're really not having any displacement there. You're just standing there as the world turns below you. But along the equator, you have to cover 1,670 kilometers each hour in order to complete the over 40,000 kilometers of the circumference of the equator. So therefore, you have more distance to cover. You're going to have to move faster. Okay, let's kick that up a notch again. Right? When we look here, we can see that as you move toward the pole, your rotational time is going to get slower and slower. So if I have a parcel of air that's moving from the equator going toward the poles, it was already accustomed to moving faster to the right. And that, again, is part of this Coriolis effect idea that winds are going to curve to the right as they move from the pole, as they move toward the poles. Let's stop with that thought for now. So this slide actually depicts exactly what I'm saying, right? Because the air mass that is moving from the equator up toward 15 degrees north latitude, there's going to be an apparent deflection to the right. And this is really what the Coriolis effect is all about. So, large scale, we can get deflection to the right in the northern hemisphere, deflection to the left in the southern hemisphere. And this diagram shows you both when you go from the equator toward the poles and what you're going to get in each hemisphere. Definitely need to know this stuff, folks. So then we get to put some names to these ideas. So winds that are going from the poles to the 60 degrees north or 60 degrees south latitude are referred to as polar easterlies. Now, we're going to see that when we get winds coming from the lower region and moving up toward the poles, this is where we're going to get our westerlies. So we're going to get a boundary between those polar easterlies and the prevailing westerlies, and that's where our polar front is going to occur. And that really is your 60 degrees north, 60 degrees south latitude. So I know you guys got to fill a bunch of that stuff in. Again, feel free to hit pause, make sure you fill it in, and then when you're doing the homework, really try and zero in on these things. It's going to pay huge dividends. All right, now, when we talk about prevailing westerly winds, we're talking from 30 to 60 degrees north latitude. This is going to be the primary source of U.S. weather. All right, so steady winds that move much of the weather across the United States and Canada. It's a pretty big deal. So then what's the significance of the 30 degrees north latitude? There at 30 degrees, you have high pressure, you have cooler sinking air. And so when it comes down, it either is going to have to go north with your prevailing westerlies, or it's going to go south toward the equator as your trade winds. And so your trade winds end up being these winds that are coming down toward the equator. And what's really, really cool is because you have that sinking air, you actually develop a specific name there called the horse latitude. So you're not getting an east-west curvature to the wind. Instead, the air is sinking straight down. And so what actually happened is that when ships got caught on the horse latitudes, back in the day, they were reliant on wind in order to be able to move, right? They're big sailing vessels. So when the air was moving vertically up and down or just coming down, the ships would get stranded there for days on end. And one of the things they would do is, unfortunately, have to turn around and eat the horses or throw them overboard in order to lighten up the ballast on the ship and try to get it to move. All right, that was way more than you guys needed. I apologize. Kind of going off the deep end with some of that stuff. All right, near the equator, trade winds from the north and south join together. All right, and this is what we refer to as a convergence, right? So to converge, like two armies converge on a battlefield. Not the first time we've used the word convergence, by the way. But when they come together, this is where the intertropical convergence zone occurs. And that's where you have winds that are coming from the north and the south converging together, and we can actually get some moisture developing in those areas. Now, this brings us back to all of these fun terms that I've been talking about, and this makes a really great diagram. You see the polar easterlies, you see the prevailing westerlies, and then you see the trade winds. And realize that we can label them north and south. So you have the northeast trade winds, southeast trade winds, your westerlies. And then, before I talked about the highs and lows, so you have your subtropical high, you have your polar high, you also have your equatorial low. And these are all different markings at your latitudes that will determine whether the wind is going to move north or south. Is it coming toward that point, or is it moving away from that point? So just a quick side note, winds are named from where they come from, right? Just like if I got on a plane and I fly over to Germany or over to Holland, they're not going to turn and be like, oh, Mr. Weaver is Dutch. No, they're going to turn around and be like, oh, he's an American, right? Because they're going to describe me based on where I come from, not necessarily where my ancestors came from. In the same way, winds are named for where they come from. So if the winds come from the west and head to the east, we say that it's a westerly wind. If winds come out of the north and go to the south, we're saying that you have a northern wind or a northeastern wind in the case of some of the curvatures that we would have. Then we get to the jet stream. And the jet stream gets a little more complicated because here we're looking at a band of fast-moving air. Usually sits a little bit higher in the atmosphere, but to sum it up briefly, you basically have this stream or there's this constant flow of air in the atmosphere, and with that, we're going to see the effects of the jet stream in weather, right? So when the jet stream dips down from Canada, this time of year we get these polar vortex. We get these colder dips in temperature, and when it flexes up, then we can actually have some days of warmer air, right? So minor jet streams are subtropical jet streams, right? That's just getting a little technical for right now. I'll expound on that when I see you guys on Thursday. Just to wrap this all up, storms fall along jet streams and can generate large-scale weather systems. So when we pay attention to the jet stream, when you look at the forecast this time of year, it'll actually show you where the jet stream is, and if it's dipping down, what the effects are. If it's pushing up, what the effects are. All right, I know I went a little bit fast today, so I hope you guys are hitting pause and filling things in. We'll pick up with the rest of the notes on fronts, and I'll post a homework assignment for you guys. All right? Have a great day.